scientific notation. Anybody know what scientific notation is or why we use it? Ladies and gentlemen, because in the real world, you have to deal with very, very large numbers and very, very, very small numbers. Okay? If I asked you to write, you know, if you're writing a paper about how far, how wide, or how big the Milky Way galaxy is, or whatever it is, and, you know, it is 15,000 million, billion, trillion, because I don't know what comes after that, what comes after trillion. Okay? Because in math, and when you write this stuff out, you don't want to, it's so easy to get confused when there's such large numbers and so many zeros. The math people came up with a way to shorten it and make it easier to work with. Scientific notation is an easy way to write big or small numbers. Big. Today we're just looking at big numbers or small numbers. And by small numbers, I mean big decimal numbers. Hashtags. And you just need to follow these simple rules, people. It is really simple, but people just don't care enough to look at their notes or do whatever. They get it wrong. You know, they're happy with 70%. I won't say who those people are. They claim they have so much homework. It doesn't make any sense. Step number 1. So let's say I'm making this in scientific notation. Step number 1 is you are going to move / place, I don't care which way you say it, the decimal so the number is between, have we done this before?
Yes.
Huh? At 6th graders you did? 1 and 10. So if I have what I said is what, 15 billion? Where would I put the decimal in 15 billion so that that number becomes between 1 and 10? Your choices would be anything between 1, 2, 3, 4, 5, 6, 7, 8, or 9. You don't make it 10. Let me just help you out with that, because I'll see. First of all, it starts right here, correct? There's no decimal in it, but so it starts at the end. Alright? If I put the decimal here, let's just do it. I'm going to move the decimal all the way from here to right there. Because 1.5 is in fact between 1 and 10, is it not? You can agree with me, Chase. Thank you, Chase, for at least nodding your head in agreement. Do you get that? Is that a complicated thing? Do you think you could do that with any number? I think you probably could. Another way to think about it is just make sure that there's 1 digit to the left of the decimal and everything else comes to the right of the decimal. Just put that decimal there. You're your own boss. You get to do it. Step number 2. Watch how hard this one is. Write down times 10. This quite possibly is the most difficult step of all. Watch. So what do you think? Doable?
Yes.
Every scientific notation number will have these little times 10 in it. So it'll be a number of times 10. And then the last thing you have to do is there's always going to be an exponent, well 99.9% of the 10. Okay? And that's step number 3. However many, what is that noise? Places you move the decimal is your exponent of 10. Are they pricing for Christmas? However many places you move that decimal, that is what your exponent of 10 is going to be. So, I started here, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. That is what that exponent is. So, it's 1.5 times 10 to the 13th power. Just accept it for what it is. This is why it is. Do you know what 10 to the 13th power is? You should. Let's go back and put our mind back here. What is 10 to the first power? Anything to the first power is itself. What is 10 to the second power? 10 times 10 is? What is 10 to the third power? 1,000. You see a little pattern there? Whatever the exponent is how many zeros are out there. So what is 10 to the 13th power is nothing more than 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 11, 11, 12, 13 zeros. If, in fact, I multiplied 1.5 times this number, I would end up back with where I started with. But in math, we're going to do this because when we do calculations, this will just be much easier. If you've ever tried to do problems where you multiply like 15,000 times 25,000 and got mixed up with all those zeros that keep floating around, you don't know where they all go, this solves that problem, not right now for you, but later in life when you do hard math. How about that? Way happy? Good. Let's do a couple more examples. It's not any more difficult than that. I don't think they ask you to actually do any calculations with it right now. So here, some other things you might run into here. What if it was just 3,600 and I asked you to change it to scientific notation? Which you can. It doesn't have to be like super crazy big. What do? Put the decimal between 1, so make the number between 1 and 10. So where would the decimal go, Caleb?
Right after the...
You'll see the pattern. Now, if I put it after the 6, it'd be 36. After the 3, right. It's going to come after the first non-zero digit. So it's going to be 3.6. I then put times 10. How many places did I move the decimal? Grace? 3. That's it. That equals the same as 3,600. How about this one? 105 million. Now remember, you have to put down any digit that's not 0. So in this case here, I move my decimal, it's going to have to be 1.05. I have to go as far to the right as until I get to where there's nothing but zeros. So 1.5 times 10 to the Emily, 1.5 times 10 to the what? What's going to be my exponent of 10 when I make this number in scientific notation? How many places did I move that decimal?
7, 8.
Pick one and go with it. Which one? 7 or 8? 8 places. You good with that, people? Stop me there if you don't catch that. How about this one? The book says, what about here? They actually do this. 25 million. They actually put the number 25 and the word million after it. If that confuses you, how many zeros should there be in millions? How many zeros follow something in millions, Chase? 6. What would this be in scientific notation? If it helps you, I suppose you'd have to write this out in digit form. 25 million. What is that in scientific notation, Emma Miller?
2.5 times 10 to the 8th power. Wait, no. Yes.
1, 2, 3, 1, 6, 7. You only moved it 7 places to get there. There's 7 digits there. You with me on that? Now, lest you think that life is good, Joseph, not only do you have to be able to change a normal number into scientific notation, but you got to be able to go the other way. Change scientific notation into a regular number. So, if I had something like this, 7.88 times 10 to the 9th power, what number would that stand for in non-scientific or standard form? What do you suppose the rule is? The rule would simply be this. You just need to move the decimal to the right that many places. I need to take this decimal, which is right here, move it to the right 9 places, and that's where my answer is going to be. So, There's a couple different ways you can think about it. You can write this 7.88 and then do it 1, 2, 3, 4, 5, 6, 7, 8, 9, and put zeros in all of those little spaces there. And get rid of this thing and put commas in there, which would make it comma, 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 78880. Or maybe a simpler way to think about it would be what? You are going to add zeros, but how do you know how many zeros you add? I don't add. Notice I did not add 9 zeros there. Why not, Lauren? If it would have just been this, 7 times 10 to the 9th power, then I could have just added 9 zeros. But it's not that. How many zeros did I have to add, Lauren?
7.
Because the other 2 came from those digits that weren't zeros. You with me on that? Does that make any sense to anybody? Am I way over the 7th grade head? Am I below the 7th grade head? How about this one? 3.02 times 10 to the 5th power. In standard form, not scientifically speaking, this would be who got an answer? Who thinks they know? What is that awful noise? Aaron says 302,000. Is that right? Yes, because it started here. 1, 2, 3, 4, 5. Again, something to think about is you're moving the decimal 5 spaces. 2 of them get taken up with that, so you're going to add 3 zeros to give you a total of 5. I don't know. Could be good, could be bad. Might be something more. Is there something else here? Because eventually we get to where we do multiplication and division using scientific notation, but that is another story for another day.